Okay, so now it's time to get a way to flow our images from our directories into our model. So we're going to use an API from Keras. So from tensorflow.keras.preprocessing.image, we're going to import the classic image data generator. Okay, let's import that, and now that we have that, we are going to create a generator with our images. So let's start by giving it a variable, and let's call the image data generator, and let's divide everything by 155. This is very common. We're just normalizing our image. We don't want to have like the range from 0 to 255 on the each pixel value. We want to normalize it to smaller values. This will improve like the performance of our network. That's very common in deep learning in general, but let's keep going. So let's create our training generator, and this will be our image gen, and we're going to use the method flow from directory. So this image data generator is something very powerful. So you can change an image on runtime. So if we try to see the options that we have available here, we can see that we can, for instance, rotate like the image. We could like shift it a bit. We could increase the zoom. So this is called data augmentation. We're not going to use it here, but it's something that you should be aware, and it's very, very powerful. We are going to keep it simple for now. So let's get here the training path. So this is one of the arguments that we have to pass here on the flow from directory. We can also set the target size. Although we did it before, we want to make sure that each image has a 175 by 175 size. Okay. Let's also give it a batch size of 128, and the class mode is categorical because you can guess, yeah, we have 5 different classes, 5 different celebrities. So cool. That's for our training. Need to do the same for our validation. We just want to reduce a bit the batch size to 32 because we have less images. And here it's validation path, and again is our validation generator. You can run it, you can see like the amount of images that you have, the number of classes, so 1466 images belonging to 6 classes, and 369 to 6 classes, meaning training and validation. So if you got these results, congratulations, we are in a good way and we are ready to start our model, finally, after such a long time. So let's start actually by getting some classes here. So let's call it like something like classes. And we want to take it from our train gen. So if we go into our train generator, we can see that we have something called class indices. And yeah, so let's just see what it is. And we can see that we have our classes, right? And we have a number for each class. So our outputs and what we are passing into the neural network, it's a number. We're not passing like Adam, right? Uh, Neural networks don't like difficult things like strings, so they'll rather have like numbers. So our y, our output, is a number here, right? And we want to extract that to a reverse dictionary to be able to access the predictions easily in the future, right? So let's do that. So let's just take from all the items into this dictionary with a mapping of our output. We want to take, we're just reversing the dictionary. So for key training. Okay, so you can see it that we just reversed the dictionary and we are going to save it as classes. Something like that. Okay, good. So now it's time for the model. So let's start by using uh, line to clear sessions in case we would like to start our models and play with hyperparameters. So I usually add this line always when I'm training any model, so it's just clean the session. It's up to you, it's not necessary, but you have it here. So first thing is like we're going to use a sequential model, of course. This is the classic CNN, so no surprise here, but let's do it. So the first layer will be conv2d layer. We're going to have 32 filters and 3 by 3. We want to have an activation prelude. We can add some pathing, again not necessary, but we don't want to miss these 2 pixels on the edges. And the input shape, it's going to be the 175, 175, and 3 channels. So the 3 channels because RGB, right? So we have the color channels here. We can add, or we must add, like max pooling, of course. So just max pool D and 2 by 2. So let's add more convolutions here. I would say like around 4 convolutions, even 5 convolutions. That will be uh, enough. Yeah, let's try with this amount. Just remove this. Okay, one more. Good, and let's also change the number of the filters because we don't want to have them 32, 32, 32, blah blah blah, right? So let's increase it here from 32 to 64, also 64. Can go a bit higher here. We're going to take a look on the model summary. It's always a good indication on how much should we keep going with the convolutions. But the next step is just a flatten layer. We want to flat this to a 1D array. We can add some dropouts. So let's do that. And drop outs. Let's add it like 0.3. We want to get, and we want to add some our DNN, our dense layers. So 512 here, the number of neurons, activation ReLU. So the same here, but 128 activation ReLU, and maybe here let's add another dropout layer, and we can do our final output layer, dense layer with just len of 5. It's actually 5, the number of classes that we have here. You can pass it manually. If you want to get a bit fancier, you can go into the train gen and just take the class indexes that we used before, and you can get the 5 there. But there are many ways to do it. You can also take the len of the CE, right? We have there our classes, our outputs, and finally our activation will be softmax. Get some probability. And class indexes is just a mess. And here we go. Let's take a look into our summary. So we can see that our neural network, it's ending on 5 by 5. Okay, so it's actually good. So our features still have some information here, right? I think this is a good model shape. You can argue with that, you can make your own modifications, that's granted, but the important thing is that we reach a point where we have some pixels left, right? So let's now just compile it on training. So compile the model. Here I'm going to use Atom Optimizer. Need to reinvent the wheel here, and loss. It's going to be categorical. Cross entropy, of course, and just accuracy as the metric. Not matrix, metrics. Finally, let's just fit the model. So the moment it will be waiting, the actual training of the model is here. So let's just give it the train generator. We want to pass the validation data, and it's just our valgen. Yes. Want to set the epochs to be 100 or something like that. And we can even add some callbacks just to get some early stopping. So let's do it really quick. So early stopping, avoid some overfitting here. And the early stopping, it's going to be Keras, callbacks, and early stopping. Just add patience of 10 epochs, 12 epochs, and some checkpoints even. So since we are on the callbacks, let's add some checkpoints here, and we can Keras, callbacks, and model checkpoints. Here we're going to save it as save faces F5, and let's just save the best only. Set it to true. Okay, so this was a really quick callback generator, but like we are using the early stopping because we want to stop when the validation loss is not like getting improved, right? So we can use again another very useful API in Keras for the callbacks, and this is going to stop the training when we are not learning anything new, right? We're not just overfitting the model. And the same here, we are just creating some checkpoints where the model will be saved every time that the new validation accuracy is met. So let's just now get our callbacks into our model. We have to pass it as a list. Let's add early stopping. Now we can run it. That way we can IntelliSense and the model checkpoint. So next we define the steps per epoch. So steps per epoch. And we want this value to be the result between the training examples, the number of examples, and the batch size. But we want the ceiling value. So let's use math to help us. So math.ceil, and let's take the train examples and divide it, so getting the integer division here, by the batch size, that in our case is 128. We also want to do the same for the validation, so let's take the validation steps, and we are going to use the same function, math.ceil, and we're going to take the validation examples and divide them by the batch size on the validation dataset. In this case, it's 32. So let's do it by 32. And let's just train the model. Okay, so it seems that it's finally over. In 28 epochs, we reached 98.7. Our accuracy and our validation accuracy, it's also 87.5, so very good results. So let's now plot our accuracy against the validation accuracy, and we can access it from the history.history. And here let's just take accuracy, and let's take the validation accuracy as well, and see our plot. So we can see that the training accuracy, it actually increased very steadily, so it's very good, and the same for the validation accuracy that followed it. So let's do the same for the loss now, and see how did the loss decreased. So yeah, looks very good as well. So the training loss decreased, and we can see that the validation loss stopped decreased on the 7th, 8th epoch, but it was still not bad, so it was still there. So now it's time to get real life proof that our model works, right? We want to see if it can recognize faces. So let's firstly import the best model because we use the callback to import the model. So let's get it from our Keras API, and we have the models method, and inside we have the load model. And I think it's faces.h5. Let's try. Yes, it worked. So now it's time to have this real life proof. So go ahead to Google and look for pictures of these 5 celebrities. So Andy Samberg, right? Just be careful to take actually JPEG images, so JPG, and I would recommend you to go into the full picture, right click, save images as, and then save it in our root folder, and yeah, just take whatever image you want and let's test it. But before we can test it, and I already have my sample here, you can see that these images are not just faces. So you can see bodies here, but we trained our model on faces, and faces only. So to get some accuracy, we actually have to get the faces first. So we can use our function getCorrupt that we wrote before, and we just have to pass our root directory where we saved our files. So if you're saving it in a different file, just pass a different path here, and let's see the results. So let's go again to the folder, and yeah, now we have just faces. So we can see that there are no bodies. That's good, our model likes that. So next step is to grab all the JPEG images from that folder. So we can just use a list dir, OS list dir, and we can take it from our root directory. And we have to do a bit of list comprehension, so we can say e for e in all the files and folders of this directory if e ends with, and just the normal JPEG format. Let's set it this to images, and you can see that now we only have the images instead of all the trash in that folder. So let's start with a simple loop. And we want to start by opening the image. So I will show you a third technique to open images. This is the third. We tried with CV2, we tried with Peel, and now we're going to use Keras to help us out to open the image. So we can use the pre-processing, and inside the pre-processing we have image, and inside the image we have something called load EMG. So we can just pass our path, and we can then just pass like a target size. So it's very handy. To be honest, it's more functional than probably the other two, but it's also heavier. So let's also pass the images to array method, because right now we have an image, but we want to have an array. So let's pass the image to array. Here we're just going to pass our image and divide it by 255 to normalize the image, and we can show it. So let's show it and see our images here. Okay, so that's good. We have Arnold here. Let's just look. Yes, we don't have the plt.show, that's why. Otherwise we'll have all the images showing. Yes, so pretty cool. Now that we have these images, we actually want to get a prediction. That's our goal, right? So we can just call model.predict, and inside a prediction, we can pass our image. And now this may sound weird, but our image, like if we print the shape of our image here, and let me just comment this for a while. So let's print image.shape. We can see that like we have uh, an image and the 3 channels. So that's not enough for our model because it's expecting like a unity before, a different shape. So it's expecting a shape of 1, 175, 175, 3, right? Because we were training it with 128 batches and we're training it with 32 batches, but we cannot pass like this shape. This is not valid. So we're going to use a simple trick to actually add this extra dimension. So we can just go into the image and just add tf.new axis, and we're just rolling up our image here. Okay, so now if we print this shape, and let's again forget the prediction for a while, we can see that now the new shape is actually pretty good. So that's exactly what we are expecting, and the model wants this shape. So that's good, and let's use it to get some predictions. Cool, now that we have that, we just have to take the np argmax to take the highest probability on the prediction, because the model is making a prediction for the 5 classes, but we are just interested to see the one that has the highest probability. Okay, and with that we have our final prediction, guys. We did it, and we can test it, but instead of having numbers from 1 to 5, we want to actually have the names of the celebrities. So if you remember, we actually wrote like a small dictionary comprehension to reverse the dictionary to have numbers to the names of the classes again. So let me show you. And here you can see that the model is going to output a prediction in a number. And we want a name. So we're just simply going to take that classes, and we are going to pass our prediction, our index. And that's enough. So I guess we can just print it. And we can also, yeah, that's good enough, I guess. Let's see what we get. So first prediction, Arnold Schwarzenegger. Checks. Good, the model got it right. Let's see the second one, Adam Sandler. Great. Adele, Arnold, Adam Sandler, Andy Samberg, Arnold Schwarzenegger. So the model works, guys. Please test it. Do whatever changes you want. Play with the hyperparameters. But we got like a simple model working. So hope you enjoyed it. So stay tuned for more content, and thank you for watching.